In question 3 we have a table here and a cubic equation. Okay, part A, complete the table. We have the value here -1 and 1 and 3. Okay, so we will use our calculator. Okay, x cubed minus 1 cubed, okay, inside brackets -1 cubed plus x is -1, or inside bracket again -1 squared, okay, -5 times x, -5 times x is -1, this will be 5, okay, here 5. Okay, the second value x equals 1, so we will only remove this negative sign here. Okay, equals -3, and here's the last value of x is 3. Okay, again delete this one and put 3. Equals 21. Okay, in part B, draw the graph of y equals x cubed plus x squared minus 5x for interval from -3 to 3. Okay, we have the values here, -3 and -3. Here's this big square with value of 5. Okay, so we need to calculate the small squares here. 1 2 3 4 5 6 7 8 9 10. So 10 small squares represents 5, so each 2 small squares represents 1. Okay, so -3 is here on x and -3 on y. We will go down by 6 squares. Okay, 1 2 3 4 5 6 will be here. Okay, this is -3 on y. Okay, the second point on the table in the table is -2 and 6. Okay, here -2. Okay, this line for 5. Okay, we need to add 1 on 5 to be 6, so we will count 2 small squares. Okay, our point will be here. The next point is -1.5 on x. -1.5 is here. Okay, and the corresponding value of y is 6.4. 6.4. This was 6. This will be 6.5. Okay, so we can mark our point here. Okay, the next point is -1 and 5. -1 and 5 here. Okay, 0 and 0, 1 and -3, 1 and -3 is here, right? Yes. Okay, 1.5 sorry, 1.5 and -1.9. It's 1.5 here. -1.9 is very close to -2, so -2 will be here. Okay, like that. The next point is 2 and 2. 2 is here on x and 1 2 here on y. Okay, 2.5 and 9.4. 2.5 here, 9.4. This 10, so this will be 9, so 9.4, maybe here like that. Okay, the last point is 3 and 21. 3 here, here is 20. Okay, and 2 squares, 21. And we will draw our graph. Okay, it will be like that. Okay, so this graph for cubic function. Okay, in part C, use your graph to solve the equation x cubed plus x squared minus 5x equals 0. Okay, equals 0. This means that we need to identify or look for the points intersecting intersecting points with the x-axis. We have here this point. Okay, this may be negative 2 point maybe negative 2.9 or 8. Okay, negative 2.8. okay, here negative 2.8, and the other point here is 0 and 0. Okay, or 0, and we have another point here. Okay, this may be 1.7. okay, so we have 3 points. The first point is negative 2.8 and x equals 0, or the last point was 1.7. okay, in part D, by drawing a suitable tangent, find an estimate of the gradient of the curve at x equals 2. So we will go to the graph. Okay, here x equals 2 is here, so we are required to construct or draw a line. Okay, like that. This will be our line here. Okay, and we want to find out the gradient of this line. Okay, to find the gradient of any line, we need to know at least 2 points. Okay, we already know a point here is 2 and 2. Okay, so try to find a suitable point. Maybe we have a point here. Look at this point here. This point, the x coordinate is 2.5. okay, and the y coordinate is 7.5. half of the distance between 5 and 10 is 7.5. okay, so we will use these 2 points, okay, to calculate the gradient. Okay, this point here is x1 and this is y1, 2.5 is x2 and 7.5 is y2. So the gradient, okay, is y2 minus y1 over x2 minus x1. y2 is 7.5 minus y1 is 2, and x2 is 2.5. okay, minus x1 is 2. This will be the calculator. Okay, $11. Okay, it's an estimate. Okay, if you find it 11.5 or 10.5 or 12 or 13 like that. This, all these values are accepted. Okay. In the last part of this question, part E, write down the largest value of the integer k so that the equation x cubed plus x squared minus 5x equals this k, okay, has three solutions for x greater than or equal to negative 3 and less than or equal to 3. Okay, we need the largest value of this integer. Okay, three solutions. We can see that the three solutions can start from here. If we draw any horizontal line, will cut the graph in 3 points, so this means three solutions, but we need to go up to find the greatest value of this line, this integer. Okay, you can find here this 5, this point here is 6. Okay, we will go to 6. Okay, we have here 1, 2 and 3 points, intersection points. Okay, so we can find that the largest value of k is 6. Okay.